Okay, welcome to our first podcast of our new unit. Where are we at? We are on Unit 8, and we are going to be looking at balancing and types of chemical equations. So the PhET you looked at, hopefully that explained. I know you guys have had this in middle school, and we're just going to enhance what you learned in middle school. So in the PhET, we talked about how everything has to be balanced. Now a lot of it, we're going to put equations in word equations into our symbols and be able to go back and forth. This is where I said now you've known our words, we can make our formulas and our compounds. We're going to put them together to make our sentences. So some of the other things we're going to be seeing. So if you see the word yields, produces, forms, you know you're going to turn that into an arrow. Another one would be just even mixes with, that means a plus sign, added to, again, turns that into a plus sign. So we're taking those words and we can turn them into our chemical reaction. Sometimes you would add a heat triangle or a heat. Sometimes the triangle might show up above an arrow. Not very often at this level, I'll be honest. Sometimes it might say, though, you have something plus heat. Okay, or it's going to say something happened plus heat. This just would mean, in this case, that heat is given off, versus in the first one, that heat is added. You don't balance the heat, it's just extra information. And sometimes we give you extra information. Anytime something's written over the arrow, that is, again, something was added to the reaction, but you don't have to balance it. This was a catalyst, so you don't balance anything over the arrow. You're just saying, oh, okay, thank you for the information, and you move on. State symbols. If we say you need to include the state symbols, we're going to work our way up. Some of the ones that are pretty obvious, then we're going to be using, and we're going to talk in a few weeks how I know if something's going to be aqueous or a solid, but we also say in words. So if it says iron, or if you look on the periodic table and you know it's a solid at room temperature, that's how sometimes I know it's solid. I also remember all ionic compounds are going to be solid. Okay. This is without water. Oops, without water. Liquids, these tend to be your molecules. Gases, also molecules, covalent. Okay. Aqueous, dissolved in water. This is different. Okay, what you're going to be doing is starting to tell me a story. And it means a difference. Because I can have NaCl, solid. Picture it. It's white. It's crystals. You add it to food. Okay, that's sodium chloride solid. I can have NaCl, liquid. You've taken that salt and you've melted it under a Bunsen burner. You have NaCl, gas. Okay, you've heated it so high you've changed that liquid to a gas. You have NaCl, aqueous. You have salt water. So by the state symbols, you are telling me more information that really is pretty important as we start going through it. Okay, the steps are all written here. Let's just kind of look at them. Hopefully by going through that PhET, it kind of reminds you of what you did in middle school. If you didn't really understand it in middle school, maybe it's making a little bit more sense. Okay, but why does it matter? So the balance equation is going to tell me how much reactants and products. Okay, down here. I'm going to start assuming, we are going to start assuming that if we talk about the reactants, you know which side of the arrow to look at. You need to know this. This is so important. You need to start speaking in chemistry. And in chemistry, the reactants are the left side of the arrow. They are going to react to produce. Look at your products are what you made on the right side of the arrow. You need to know that, because it's going to tell me a balanced equation is what I use for my stoichiometry. How much am I going to make? It's going to tell me a balanced equation, tells me the ratio. Well, I need 2 parts hydrogen to every 1 part of oxygen, and I get out 2 parts of water. It tells me a balanced equation if it's reversible. This really isn't something we're going to worry about so much at this level, but when we start looking at the equations, a forward arrow means it's pretty much in one direction. If you see something with a double arrow, that means it can be reversible. Okay, those steps. If the compound is already written, you can skip this sometimes. Okay, this is a maybe step. And unfortunately for you guys, or fortunately for you guys, excuse me, that you in pre-AP will be seeing step 1 a lot more often. That we are going to give you the words, and you're going to have to turn the words into the formulas. So this is where you make sure you put the formulas for the reactants on the left side of the arrow, put the formula of the products on the right. You're going to separate them with a plus sign and put an arrow in between. Okay, then we're just counting. Now, some people like making kind of a T-chart, and you can list out and say, oops, sorry, there's Smoko. List out how many hydrogens, how many oxygens on both sides. And you can kind of use this and go back and forth. It works. I will be very honest. If you have to do this on every equation we balance by the end of the year, you're not going to finish test. You need to get where we can be doing this in our head. It works in the beginning, but balancing an equation, you need to be able to see what's going on and being able to balance it faster. So we're trying to go through some hints. Use a coefficient, okay, some of the vocab. The coefficient is the large number that goes in front. So if I have a coefficient, then that means it's going to go affect all of the compounds. Okay, let's see, and here's another hint. This is a good hint. Leave oxygen and hydrogen to last, especially if they show up in more than one compound. Leave a single element to last. And all of these, when we start going through them, I'll kind of point them out. Never change subscripts. Ever, 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 because you're going to change the formula. You can only change the coefficient. Now, saying that, if it's not balancing, go back and check your formulas. A lot of times your formulas aren't written correctly, and then you do need to change your subscripts. Okay, you go back, double check. Okay, last thing, you want to make sure that everything's at the lowest possible ratio. I'll show you some examples of this. Okay. Before we even go to this, find a place. And this is when we're counting and we talk about the coefficients. Let's go on this side, so not distract. If I have, let's see, ammonium phosphate. Okay, so when I am counting, now when we're doing molar masses, I would say this as 3 nitrogens, 12 hydrogens, 1 phosphorus, and 4 oxygens. Okay, what I'm talking about with polyatomics, I see this as 3 ammoniums and 1 phosphate. I really don't care about the charge, but it's automatic with me. I put the charge. You don't have to worry about that. So when we say count the polyatomics, that's what I'm talking about. Okay, now if I put a 2 in front of this, this means then you would have 6, because 2 times 3, 6 ammoniums. This 2 goes to the phosphates. You would have 2 phosphates. So when you use a coefficient in the front, you're changing everything with that compound. Now if it was just a compound, let's say it was calcium phosphide, then I'm going to count atoms. This is just 3 calcium ions, 2 phosphoruses. You put a 3 in front of this. 3 times 3 would give me 9. 3 times 2 gives me the 6. So that's what I'm doing when I go back and forth. And when I say you put a coefficient, the coefficient affects all of the compounds. But you see a stop sign, it only affects the compounds before the stop signs, or just that individual. Okay, so we look here. Typically I hear, where do I start? Odd, even. That's my hint. Look at odd, even. What do I mean? I have 2 chlorines, which is even. I have 1 chlorine, which is odd. And also don't think in terms of adding, think in terms of multiplying. Because nothing I can multiply this 2 by will ever make it odd. So I need to make this even. So don't think I need to add one more. Think this is 1. Remember, everything's 1. I need to multiply it by 2. So you multiply it by 2, and this is where I said you could start in the beginning and say, I have 1 sodium, I have 2 chlorines on this side. You probably did a T-chart or something in middle school. Okay, so let me forget that I did that. In the beginning, you would have said I had 1 sodium, but I had 1 chlorine. Okay, they're not balanced. So think multiplying. This is where I would have put the 2. What did that do? Change that to a 2. Change that to a 2. You look, they're not balanced. I call it ping pong. So now you have to fix what is not balanced. So go over, put a 2 in front of the sodium. Now look at what's happening. Everything is balanced. I go back and double check. I just go 2 sodiums, 2 sodiums, 2 chlorines, 2 chlorines, because the 2 goes to front. It's balanced. Okay, so down here I look at odd and even again. I see chlorines, even, odd. We're going to make it even. What did you just do? You just made it have 2 hydrogens. So then you check. It's a guess and check. Well, I have 2 chlorine, 2 hydrogens, 2 hydrogens. Well, that's good. 2 chlorines, 2 chlorines, 1 zinc, 1 zinc. That's all you had to do. Okay, KBr, magnesium chloride. Again, look at odd, even. And where I start, you might start in a different place. That's okay. I just kind of look for what jumps out. I just saw this chlorine first. So I'm going to fix it. This gave me 2 chlorines. Now I have 2 potassiums. Fix your potassiums. So I'm going to jump over to this side. This is where I said ping pong. Now I have 2 potassiums. It's fixed. That gave me 2 bromines. Pong over to this side. 2 bromines. Okay, it's fixed. 1 magnesium, 1 magnesium. It's balanced. Okay, the number inside the parentheses, remember the 2 goes to both of them inside the parentheses. Now this is where you have to be careful because I have a hydrogen here and I have a hydrogen here. So when I add them up on this side, I have 2 plus 1. I only have 3 hydrogens on this side to begin with. Look at here, I have 2 hydrogens to begin with. So I could start with the hydrogens, but we said, you know what, let's start with those last. Okay, let's fix this. 2 iodines. Let's fix the iodines first then. 2 iodines. So this is going to give me 2 plus 2, 4 hydrogens on this side. So I need to have 4 hydrogens on this side. So you're going to put a 2 in front. That gives you 2 oxygens. Come over here, 2 times 0. This is also 2 oxygens. So I do have 2 oxygens. Should be a big O. Look at the 2 doesn't go to calcium. So I only have 1 calcium. But that's okay. Look at on this side. I only have 1 calcium. So it is also balanced. It's good to go. Okay, now ones. A lot of times on the district test, they're going to put in ones. You like to put in ones, you can absolutely put in ones. I just don't use ones. We assume the ones are there, but if you like to use the ones, you can put in the ones. Okay, turn the page. That last one on the top there, number 5, that's for you to do. I want to look at how things are going to get. Are they going to get any harder? Well, a little bit. Look at the words. We need to turn the words. So what do I know? Zinc. Zinc is zinc. Okay? What do I know? Zinc's a solid. We'll get to the point. We're not going to worry about it so much right now, but we know the zinc is a solid. Hydrochloric acid. Oh my gosh. Okay, remember. Hydro means no O. So hydrochloric acid is HCl. It'd be an acid because it's aqueous. Don't stress on the states right now. Zinc chloride. Well, zinc is always a +2. Chloride is a -1. So the formula would be zinc chloride. And then hydrogen is a gas. Oh wait, this is where those 7 elements, remember? We have nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen. These are your 7 elements when they are by themselves in equation are diatomics. Hydrogen is by itself in equation, so I have to put H2. Okay, one thing that's really important. Don't worry that chlorine doesn't have a subscript on the reactant side, but it does on this side. You're making something new. These are chemical changes. They're not going to be the same. Then that's why you come back and balance the equation. So now I look and say, okay, I need 2 chlorines. I'm going to put a 2 here. So 2 hydrogens, 2 hydrogens, 2 chlorines, 2 chlorines. We are good. It is now balanced. Okay, so aluminum carbide. Aluminum plus 3, carbide minus 4. So we know the formula then, and we're not going to worry about states right now. Aluminum carbide, they're going to switch. Al4, okay, C3. Carbide comes from carbon. Reacts with plus water, H2O. It would be a liquid. To form arrow, methane, okay, give you the formula for it, and aluminum plus 3, hydroxide minus 1. So when I write this formula, OH3. Okay, it's so important, so important. Don't forget the parentheses, because then things don't balance if you forget the parentheses and you drive yourself crazy. Okay, another place to start. I start for the most complicated. What that means is something with the highest subscripts. Look at this, with the highest subscripts. Okay, what am I looking at? Okay, highest subscripts. Those are pretty high as I'm looking at that. So I'm going to try to fix that first. So 4 aluminums, I'm going to come over here and put 4 aluminums. I'm going to go ahead and fix the carbons because I'm going to do hydrogens and oxygens last. And a lot of times you take care of everything else, they take care of themselves. Now sometimes I write down the numbers myself because they get kind of big and I don't want to make a mistake. So what I'm saying that is I have 3 times 4, this is 12 hydrogens in this compound. And then I'm going to have what? I have 3 hydrogens, but it's a 3 times 4, so that's another 12 hydrogens. So that means you're going to have 24 hydrogens total on this side. Okay, let's check the oxygens. I have 3 times 4, you're going to have 12 oxygens. Oops, oxygens. I don't know where that came from. Oxygens. So it's a 2-to-1 ratio, which is really good because water's in a 2-to-1 ratio. So you need to have 12 oxygens, 24. That means you're going to have to put a 12 in front. Sometimes we deal big numbers. Don't freak out. It just happens. Wait till we get to combustion reactions. Okay, so sometimes they are harder. Sometimes they're easier. First one was easy. Sometimes they're a little bit harder. Let's do one more. So a solution of potassium bromide. Potassium plus 1, bromide minus 1. So KBr. This word solution is your key. It's aqueous. So if I was doing states, I knew that I would say aqueous. Is mixed with, turns into a plus sign. Plus. A solution, barium, group 2, plus 2. Acetate, C2H3O2 minus 1. So you're going to have barium, okay, acetate. To form, turns into an arrow, potassium plus 1, okay, acetate minus 1, okay, C2H3O2, and barium, we know is a plus 2, bromide minus 1, those hasn't changed the charges, so BaBr2. Looks scary, we're going to realize it's really not that bad. So look at right here, this is where this whole thing is acetate. C2H3O2 is acetate. Don't drive yourself nuts. Don't try to count all the carbons, the hydrogens, the oxygens. This is acetate. There's 2 outside, that means you have 2 acetates. I need to have 2 acetates over here. Put a 2 outside. So then you have 2 C2H3O2s, if you want to kind of put a parentheses. Then you have what? 2 potassiums. So let's have 2 potassiums on this side, 2 bromines. There's 2 bromines, 1 barium, 1 barium. So we are balanced. Okay, looking at the next of them. Why don't you try the next two? And that'll be a good things to kind of practice. Give us a starting place, and then we'll work on the rest of them in class and come with questions. Write down questions. Is it, how do I get started? What am I doing? I don't understand this. This is the main point, is you have to come with questions. We will see you on our next day.